All right, hypothesis testing video 2. So remember, null hypothesis, nothing's happening. Research hypothesis is the thing that I'm doing is making a difference. Meditation app is reducing anxiety-related insomnia. So how do I go about doing this? What I want to do is do some mathematical computations, which I'm not going to make you do by hand. Do some mathematical computations where I can look at the null hypothesis, because obviously I'm wanting the research hypothesis to win. So I look at the opposite one. I look at the null hypothesis. And I say, if this were true, what are the chances that I would get the result that I'm getting? Okay, you've used the app, you've given me your sleep data, I have all of my numbers. As I'm trying to see, are the students who use the meditation app sleeping better? What I am doing in essence is I am looking at their numbers and I am saying, what are the chances that the students who used my app would look like this if there was absolutely no impact of this app on sleep? So considering standard variability, as we talked about, right? If you've ever suffered from insomnia, you know that you can still have a good night's sleep every now and then. It's not necessarily every single night, right? So you would expect in just a standard population of people who have insomnia that, yeah, sure, there's going to be some nights you're sleeping okay. And so what I need to do is say, okay, what are the chances that I would see this pattern of sleep that I'm seeing if there's absolutely no relationship here? And I want to set a number where I could say less than blank percent of the time. Our standard in psychology research is 0.05 or 5%. So I want to be able to say, I would see the results that I'm seeing less than 5% of the time. There'd be a less than 5% chance I'd be seeing this if this null hypothesis is true. Now, sometimes researchers take it further. They'll say less than 1% or less than 0.1%. But this is the math that we're doing. This is the logic behind the math that we're doing. This is the complicated stuff your textbook was getting at, is if this is true, I can only show, we don't use true and we don't use proved. If this is supported, the way that I am supporting this is by showing that there is a very, very small chance that I would have gotten the numbers that I am getting if there was absolutely no relationship there. Hopefully that makes sense. Okay. If you are still stuck, email me. I can try to find some other way to explain it. Now, the way that we do this, backing up, so that's kind of the logic behind what we're doing. The way we do this is we're going to be using 2 groups. Now, when you get more complicated research, you might have more than 2 groups. For the sake of these examples, we're doing 2 groups. Our population number 1, our group number 1, is our research group, our experimental group. So in my example, population 1 is the students who use my meditation app. Okay. Population number 2 are these over here with the null hypothesis, the general population, also called the control group, the students who don't use my app. Or the textbook gives an example of having national level statistics that you're just comparing it to the national average. Either one works. So I have 2 populations set up that I need to compare in order to see what are the chances, right? So I have a population that's going along with my research hypothesis. They're getting the thing that I am doing. And then I have another population that's not getting any special treatment. They are just standard. And I'm trying to see if there's a difference. And remember, the null hypothesis would say they're exactly the same.